Hi students, so in the previous session we have discussed about questions related to exponents and powers, the laws of exponents, where to use the law of exponents, how to simplify and how to express the exponential form. Still we have some of the questions from the same exercise, 13.2, expressing the numbers as a product of their prime factors in the exponential form. Question number 4. Look at the question number 4, that is, express each of the following as a product of prime factors only in exponential form. So as a product of prime factors only in exponential form. 108 into 192, first bit, and third one is 729 into 64. Let us see, each one you have to express as a product of their prime factors, so exponential form only. So first, prime factorization, as prime factors only you need to get. So prime factorization of 108. Prime factorization of 108. So here you will see that 108. So 108, 2 table, 2 5s are 2 2s are, 2 5s are 2 4s are, 2 2s are 2 7s are. Next, 2 not possible. So 3 9s, 3 3s are, and 3 1s are. 108 can be written as 2 into 2 into, observe it, 3 into 3 into 3 into 3, which you can write 2 2s are 4, 4 3s are 12, 12 into 3, 106, 106 into, 12 into 3, 36, 2 2s are 4, 4 3s are 12, 12 3s are 36 into 3, 108. So 2 how many times we have? 2 times. 3 how many times we have? 3 times. So this could be written as 2 to the power 2 into 3 to the power 3. This is the prime factorization of 108 separately. But into is there, again 192 is there. So let us see now prime factorization of 192. So prime factorization of 192, let us try first, then we multiply. 192. So 2 table, 2 9s are 18, 2 9s are 18, 1 remains 12, so 2 6s are 12, 248, 224 and 212. You know how to do the prime factorization. Since class 5th we are learning. Even in class 6th also we learn how to express in playing with numbers chapter. So 2 6 and 2 3, 3 1s. Observe it. 192 could be written as, so 192 could be written as 2 into 2 into 2. Like that, how many times we have? 1 2 3 4 5 6. So 2 into 2 into 3 is equals to, you see here, 2 how many times we have? 1 2 3 4 5 6, repeatedly multiplied. So 2 to the power 6, laws of exponents only, a to the power n into a power n, a to the power n plus n, we are adding the powers 1 1 1 into 3 to the power 1. Now you see 108 into 192 we need to express. So 108 could be written as 2 to the power 2 into 3 to the power 3 into 192 we can write as 2 to the power 6 into 3 to the power 1. Now we observe 2 to the power 2 into 2 to the power 6. Write at one place 2 to the power 2 into 2 to the power 6 into 3 to the power 3 into 3 to the power 1. See, here you see a power m into a to the power n. A to the power m into a to the power n is equals to a to the power m plus n. So 2 to the power 2 plus 6 into 3 to the power 3 plus 1, which is 2 to the power 8 into 3 to the power 4. So the exponential form of this product is 2 to the power 8 into 3 to the power 4. So always you have to see that whether the prime factorization when we are doing, is it simplified till the end or not. All the prime factors, now 2 plus 6 is equals to 8 and 3 to the power 3 plus 1, which is 4. That is the prime factorization which we express in the exponential form. Is it clear? Let us see 729 into 64. If you have only one number, in that one number you can do like this. Suppose if you don't have 192, we will write like this and we express that as a product of its prime factors. Similarly here. Next, 729 into. So prime factorization of 729 we have to see that the prime factorization how can we write, then we express that as a product of the exponents like prime factors. So 729 you see 729, that is it's not divisible by 2, so let us go to the check with the 3. 7 plus 2 9, 9 plus 9 18. Yes, 1 plus 8 is 9 is divisible by 3. So prime factor is 3. 2s are 6, 1, 3 4s are 12, 3 3s are 9. Then again 3 8s are 3 1. 3 2s are 6 and 1 21, 3 7s are 21. 3 9s are 27. 3 3s are and 3 1s. Right. So 729 can be written as like this: 3 into 3 into 3. 729 is equals to 3 into 3 into 3 into 3 into 3 into 3. 6 times you see. 1 2 3 4 5. 1 2 3 4 5 6. So 3 into 3 6 times 3 and 3 to the power 6. You can write as 3 to the power 6. Let us write 64. Prime factorization of 64. Let us try for 64. Prime factorization 64. 2 3s are 6. 2 2s are 2 1s are 2 6s are 2 8 2 4 2 2 2 1. So 64 could be written as 64 is equals to 2 into 2 into 2 into 2 into 2. 1 2 3 into 2 4. Total 6 times we have, which you can express as 2 to the power 6. So now 729 into 64. So 729 you can express as 3 to the power 6 into 64 you can write as 2 to the power 6. He is asking us to express only as a product of prime factors in the exponential form. You can use the law of exponent to simplify this, but these are, if you multiply 3 to the 6, 6 power 6, 6 is not the base, is not the prime factor. As he is asking us to express product of the prime factors. Is it clear, students? I hope you understood how to express as a product of the prime factors. Right? Let us see question number 5. Simplify. 2 power 5 whole to the power 2 into 7 power 3 by 8 power 3 into 7. So you have to simplify this. He didn't ask whether exponential form. Simplify means finally maximum way can be write that we can keep. So 2 to the power 5 whole to the power 2 into 7 power 3 by 8 power 3 into 7. You see, here is a prime number, this is a prime number, this is a prime number, but 8 is not the prime number. So only for 8 we have to do the prime factorization. So 8 if you do prime factorization, 2 4s are, 2 2s are, 2 1s are. So 8 is equals to 2 into 2 into 2, which is 2 to the power 3. 2 to the power 3. Right. So 2 to the power 5. This 8 we can write as 2 power 3. Look at this. 2 to the power 5 to the power 2 into 7 to the power 3 by 8 we are writing 2 to the power 3 again whole to the power 3 into 7 power 1. If you don't have anything power, that is 1, right? Now the law of exponent you see in the numerator place a power of power, a to the power n whole to the power n. apply over here. A to the power m for the numerator and denominator separately. So a to the power m whole to the power n is equals to a to the power m into n. This we are applying for this and this one. So 2 to the power 5 into 2 into 7 to the power 3 by 2 to the power 3 into 3 into 7 to the power 1. Now 2 to the power 5 2s are how much? So 2 to the power 10 into 7 to the power 3 by 2 to the power 3 3s are 9. 2 to the power 9 into 7 to the power 1. Now we observe it here. The step is a power m by a to the power m. A to the power m by a to the power m. So a to the power m by a to the power n is equals to a to the power m minus n. This identity could be used. So here 2 to the power 10 minus 9. 10 minus 9. A power m by a to the power m. A to the power m minus n into a to the power m by a to the power n. So 7 to the power 3 minus 1. So which is equals to 2 to the power 10 minus 9 1 into 7 to the power 3 minus 1 2. Finally he is asking us to simplify the final answer. 2 to the power 1 means 2 into 7 square is nothing but 49, which is 2 into 49 is 98. Therefore 2 to the power 5 whole to the power 2 into 7 to the power 3 by 8 to the power 3 into 7 is equal to 98. So for each one we need to write therefore. Understood how to simplify? Now this is not in the exponential form. This final answer we have written here. Let us see one more question from the same. 25 into 5 power 2 into t to the power 8. Look at this. Here 5 is there, here t and t. These bases are same, but here 5, 10, 25. So power bases are different. Even powers are also different. So we need to try to change the bases as same. We go to the prime factorization of 25 and 10. So 25 you can express as 25 you can write as 5 5s are 25, where 25 is equals to 5 into 5, which is 5 to the power 2. So 25 we can express as 5 into 5, which is 5 square. Similarly you can write 10. This 25 we wrote like that, and similarly 10 also we can write as 2 into 5. So 10 is equals to 2 to the power 1 into 5 to the power 1. Let us substitute those in this place. So 25 I am writing as 5 square into 5 square into t to the power 8 by 10 I am writing as 2 power 1 into 5 power 1 whole to the power or else 1 is not necessary to write 2 into 5 as it is only one time. So whole to the power 3 into t to the power 4. Now we observe for the numerator part we have one formula, that is a power m into a to the power n. So here a to the power m into a to the power n is equals to a to the power m plus n. For the numerator these two steps. So a power m into a to the power n. A to the power m plus n. So that is 5 to the power 2 plus 2. 5 to the power 2 plus 2 into t to the power 8. Into t to the power 8 by, I am writing this step as it is 2 into 5 whole to the power 3 into t to the power 4, which we can write as 5 to the power 2 plus 2 is 4 into t to the power 8 by 2 into 5 whole to the power 3 into t to the power 4. Observe it now for the denominator part. A into b whole power m could be written as a power m into b power m. So a into b whole to the power m, we can even write a power m into b to the power m. We can write the power separately. The basis we can divide. Application, the power is applied for both numbers 2 and as well as 5. So with that, now 5 to the power 4 numerator part into t to the power 8 by what I am doing, I am separating the power for both 2 power 3 and 5 power 3. So 2 to the power 3 into 5 to the power 3 into e to the power, that is 4. Now observe it. We have the denominator and numerator. Numerator and denominator. Numerator and denominator. A power n by a power n. A power n by a power n. But 2 power 3 it is alone. So we write as it is that one. So 5 to the power a to the power n by a to the power n is equals to a to the power m minus n. M minus n. So now for this 5 to the power a power n by a power n, 5 to the power 4 minus 3 into. Similarly, a power n by a power n, 3 to the power 8 minus 4 by 2 to the power 3. Now, 5 to the power 5 minus 3 is nothing but 1. Observe it. 5 minus 3 is nothing but 1 into t to the power 8 minus 4 is t power 4 by 2 to the power 3. So 5 is nothing but 5 we will write t to the power 4 by 2 power 3, 2 into 2 into 2. So 2 into 2 into 2, that is 8. So this is 5 t to the power 4 by 8 is the final answer. 5 t to the power 4 by 8. So like this we simplify the given. T power 4 is the exponential form. You cannot simplify further. You can write only t into t into t. And 2 power 3 we can write as 2 into 2 into 2, that is 8 as a product. So like this we use the laws of exponents. Is it clear? Until now we have discussed about exercise questions 13.2, but now we are going to discuss the other topic which is related in this, that is about the large numbers, very large numbers. How to express, like very large numbers how we form, that we learned in the earlier classes by place value chart, and which place is that, how many times 1000 place, 100 place, like this. Large numbers in expanded form how to write, as well as very large numbers how to express in standard form by using standard form. Standard form is nothing but the number we could able to express are between 1.0 to 10.0. So standard form how to express like with the standard form and expanded form. Let us discuss about it. Let us see how to write in expanded form the given number. So this is ones, tens, 100, 1000, 10,000, lakh, 10 lakhs. If it is like what you can say, units, tens, 100, 1000, 10,000, lakh, 10 lakhs. Large numbers. What is the expanded form? Expanded form. See here it is in 10 lakhs place, right? Ones, tens, hundreds, 1000, 10,000, lakh, 10 lakhs. So 2 into, how you will write? It is in 10 lakhs place. 2 into, right? 1. Besides 1, how many? See these places, how many are there? 1, 2, 3, 4, 5, 6. So 6 zeros. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6 zeros. Then only it will become 2 into 10. 2 into, observe it. Units, tens, 100, 1000, 10,000, lakh, 200, 20 lakhs it will come. Am I right? So instead of that you can write another place. First you will be writing like 20 lakhs. Then you will be expressing that in terms of, this is you see 20 lakhs. So 20 lakhs plus 7 lakhs plus 30,000 plus 5,000 plus 400 plus 60 plus 8. See here, 60 plus 8. Now this can be written as 2 into 1 lakh, 10 lakhs, right? Units, tens, 100, 1000, 10,000, lakh. This is in which lakhs? You observe it. Units, tens, 100, 1000, 10,000, lakhs, 10 lakhs. So 2 into 10 lakhs. 2 into 10 lakhs. Then only you get this 20 plus 7 into 1 lakh plus 3 into 10,000 plus 5 into 1000 plus 4 into 100 plus 6 into 10 plus 8 into 1. 8 into 1. Is it clear? Now, so this 2 into this you can write as now 10 to the power. How many zeros are there? 1, 2, 3, 4, 5, 6. You see 10 square. 100 you can write as 10 square. 10 to the power 1. 1 it is there, 1 0. 10 square, 10 into 10, 100. 10 cube, 10 into 10 into 10. So 3. As many zeros are there, that much power. So 2 into 10 to the power 1, 2, 3, 4, 5, 6 plus 7 into 10 to the power 1, 2, 3, 4, 5 plus 3 into 1, 2, 3, 4 10 to the power 4 plus 5 into 10 cube plus 4 into 10 square plus 6 into 10 to the power 1 plus 8 into everything we are able to express as 10 to the power something. But how can you represent this one? Yes, you are right. We can write that one as 10 to the power 0. We can write this one as 10 to the power 0. So this is called expanded form. This is called expanded form. Is it clear? Standard form. As it is convenient to write number in this form, that's why this form is preferred by scientists and engineers. When a number is expressed as a number between 1 and 10 multiplied by an integral power of 10. Integral power of 10. 10 means 10 to the power, it can be positive or negative. A number is said to be standard form. This form of notation is also known as scientific notation. In symbol, you can write as k into 10 to the power n is a standard form of where k is a number which is terminating decimal, and terminating means which ends, and k less than or equals to 1 less than or equals to k less than 10 where n is an integer. You see how to follow these rules while representing the number in standard form. There is only one digit to the left of decimal when you express in scientific notation. Then if the given number is greater than or equal to 10, then the power of 10, that is the value of n is positive number and it is equal to the number of places decimal points has been shifted to write the numbers in the standard form, where k into 10 to the power n, the k value is less than 1 value is less than or equals 1 is less than or equals to k less than 10. For example, 529 you can observe left side we kept only one decimal 5.9 and 2 digits we moved towards left. So 10 to the power 2. So we shifted towards left side. And if the given number is less than 10, then less than 10 but greater than 10 or equal to 1, then the power of 10, that is the value of n is equals to 0. So example 6, which is 6 into 10 to the power 6. The value is greater than 1, and if the given number is less than 10 and greater than or equal to 1, then we represent like this. If the given number is less than 1, then the power of 10, the value of n is negative and it is equal to the number of places the decimal point has been shifted towards the number in the form of k into 10 power n, and where 0.0684. Now the decimal places is moving towards right side, towards actually 0.0684. So decimal places move towards right, so then the power will become negative. So like this standard form we will be expressing. Let us see that some of the questions. Here you can see the standard form or scientific notation is nothing but a number which we could be able to express as k into 10 to the power n, where k is a value, k is a number which is in between 1 to 10, or you can write as 1.0 to 10.0, like this, between 1.0 to 10.0. If it is less than, in between, then 1 is less than or equals to k less than or equals to 1. So k value will be in between from 1 to 10. K value is in between from 1 to 10. This is the standard form. How to represent? N is what? N is the power of 10. N is the power of 10. The value of n is positive when the decimal place is shifted towards left side. Here 529 is the 529. This we will be able to express as scientific notation by using k into 10 to the power something as k. The value of k should be in between 1 to 10. So I shifted the decimal point like 1, 2. So 2 places I shifted towards from right to left. Observe it. Right to left I shifted the decimal place from here to here. 1, 2. So 10. 2 places I shifted. So 10 to the power 2. Towards left. When we shifted towards left. Are you following? Next. N value is negative when the decimal place shifted towards positive. Towards, that is right side. Towards right. Our right side. So from 0.0684, it is very small number, it is minute number. 0.0684. This we are able to express as scientific notation. So the k value should be in the form of k into 10 to the power n. K value should be in between 1 to 10. I moved. Decimal place I shifted 1, 2. Left side there must be only one digit. That also remember, while representing in the standard form, left side there must be only one digit. That digit also should be in between 1 and 10. In between 1 and 10. So 1, 0.068 I shifted towards this side. So 2 digits I shifted, 1, 2. So 10 to the power minus 2. So let us go through some of the examples again. Here 6253009. How to express in standard form or scientific form? You see here, there is a number. This k into 10 to the power n. You have to get k into 10 to the power n form. So k, left side there must be only one digit. Left side there must be only one digit. Right. Left side there must be only one digit. If I write 0 here, left side must be one digit. That is, I move towards this side. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7 places I am moving. 6.253 into, because at the ends all zeros are there, we no need to write. Into how many places I move towards this side? 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. 10 to the power 7. So left side k value is in between. This is 6.253 is in between 1 to 10. 6.253, and left side it should be only one digit, that is 6. This is called standard form of the given number. Next, one more example you see, that is 0.000928. Observe it. Now this is very small, minute, like decimal number. So now 0 point. Now the digit, this you have to express in the standard form or scientific notation k into 10 to the power n, where k is in between 1 to 10. So I just will move towards this side. Left side there must be only one digit. 1, 2, 3, 4 digits. After the fourth digit, I place the decimal point like from here 1, 2, 3, 4. Here I place the decimal point 9.28 into. I move towards right side the decimal point as 10 to the power. How many places I move? 1, 2, 3, 4. So I will make as power negative 10 to the power minus 4. Is it clear? When we are moving towards left side, power will be positive. When we are moving towards right side, the power will be negative. So here the decimal point, it is positive and here it is negative. This is scientific notation or standard form. I hope you understood how to write expanded form and standard form and scientific notation. Is it clear, students? So like this we can write, we can express the given numbers, very large numbers which are unable to read, that could be expressed by using scientific or standard form, scientific notation. Left side there must be only one digit and the n value depends on how we are moving the decimal place, whether towards right or towards left. I hope you understood. Thank you.